Welcome back to Motivated Motorsports. Today we got a new little toy to play with. So I bought this a couple months ago, actually on sale, and it's taken me a few minutes to get to it. So this guy is a 3D scanner. So for those of you that don't know, my actual real job, don't mind that. My actual real job is actually a mechanical engineer, so that's what I do full-time. And so I have always been enamored by these 3D scanners. We've actually had a few of them at work, but they've been cheap ones, like a couple $100 ones. This one is a little bit more expensive. It's definitely not on the high end of stuff. I think they're somewhere around $1,000 right now. But they are actually a really good 3D scanner. Most of the 3D scanning cost comes from the actual software, and the people that make this actually make some higher end ones, but the software is all the same through all their scanners. So this is kind of one of them that I've been wanting to try for a long time. I've seen a bunch of videos on YouTube for it. A lot of car people are actually purchasing this one to scan stuff, to be able to make models and do that stuff. So that's what we're going to do today. We're going to go ahead and get this thing up and running, and then we're going to scan something and try to make a model out of it. So first off, let's get this thing unboxed. So it definitely comes in a sweet little carrying case. That's super handy. Comes with a little wipe, Chinese wipe, if you need to wipe some stuff with it. All right, so this is the scan head itself. And then we got a couple of cables in here to connect it all to the thing. Inside of here are some of the parts that you need to be able to calibrate it and such. I think there's also in here, yeah. So you have some detection dots right here. So the way this scanner in particular works, it doesn't always like super flat surfaces because it uses pictures. So it takes pictures and then compares them to each other, and then that's how it starts to build the scan off of itself and how it tracks and how it moves. So if you have a very flat surface, something really fat, so like the fender of a car, it doesn't like to track very well. These guys, if you put these in random orientations all over the fender, will help track it. So that's what those guys are. The manual's in here. And I think the only other part inside this box, yes, is another cable for the power supply. So, and that's it. All right, so I'm not going to completely unbox all this for you. I'm gonna go ahead and get it all hooked up to the computer. I'm not gonna show you the installation of the software. There's videos out there on it if you wanna go check it out. So the setup on all of this is kind of two folds. You can do a portrait or object, medium, small objects, or medium and large objects, small objects. So you can kind of do either one at this point. Select mode of alignment features. So this is where I was kind of talking about how it has different options for it. So either it can use the features around it, or it can do texture alignment, hybrid alignment, features and marks, or global markers. So the global markers are the little dots that I was talking about. So we're going to go ahead and do features because I think this one has enough features in it to be able to use it. Select resolution, medium resolution. Again, this thing doesn't have to be super close. 0.5 millimeters, that's a pretty close. You know what, we'll go down to 0.3 just to see, you know, kind of what it will scan. So most of the time it says that you're supposed to do a calibration with it right off the bat, but it does not seem to be wanting. Let me go ahead and try to start scanning. Interesting. Alright, we're gonna go ahead and stop that scan. That was a pretty good scan. Well, this is interesting. So I'm not exactly sure what to do here. I feel like it should ask me to calibrate it. Okay, so here we go. I had to go to the calibration guide. So, okay, so on the screen it kind of gives you the demo. Again, I'm not going to go through this all, but kind of essentially what it does is it has all these little dots on the plate, and it's going to make you kind of go out and then come out and then go out, go out, go out, just so that way it can calibrate itself. I think that should be what it does. So I'm going to go ahead and just click through this. So the white balance, demo video. All right, calibrating. Calibration succeeded. All right, white balance. White balance successful. Cool. All right, so for the first scan that I'm going to do, I'm going to use one of these Milwaukee M-12 batteries. So this guy right here, I have a bunch of these actually over here. So I have a bunch of the M18 batteries, and I actually have some holders that I bought, I think off of Amazon or Etsy or something like that, to hang them up on the wall. And I just recently got a bunch of these batteries, the M12 batteries, for a couple of tools, but I do not have the holders for them. So now that I used to have one or two, not a big deal, throw them in your toolbox, but now I think I have like 5 of them up to this point, 5 or 6 now. So I want to go ahead and make something that I can do. Again, I could purchase them off of Amazon, but I have a 3D scanner, I have a 3D printer at work. Why not, have some fun with it, test it out, see what it does. So that is what we're going to do. All right, so the main thing with 3D scanners is you want to get all the way around it. Now there are ways that you can kind of scan it this way, and then you can kind of scan half of it on some features, and then you can flip it 180 and then start from a direction and then keep scanning it. This, I'm going to hope that maybe putting it kind of out here, I can get as much all the way around it as possible. Here, let me try to scan this thing. You can see it in the window itself. There we go. Now let's see if I can scan it. Oh, there we go. Those are pretty cool, isn't it? Go on a bunch. Really, that's so we're going to try 30 scans. See what happens. Okay. Maybe small one and see if it's actually seeing it. I don't know why it's not recognizing it. There we go. I'm going to try this thing. Lost tracking on it. Okay. Alright, so we've lost tracking on it. And what I'm going to do is I'm going to try to put some tape maybe over it in a couple of different directions just to see if it'll catch that part. Okay, so let's try this now. I've seen this work in a couple of videos. I don't know if this is going to work in this particular one. But we can try to give it a shot and see. All right, so it's been a few days and I've done some digging. So There is a lot more to this than, you know, if you just watch a 10-minute YouTube clip, it doesn't give everything. So most of what I was working with or working against was the brightness on the screen, and you can kind of see that in here, where you can adjust the brightness right in through here. And so you kind of have to get that into a fine window to be able to do it. Also, the scan size matters quite a bit, evidently, on these things. The other thing, which I think I've already mentioned, is it's tough to scan black objects. So it just doesn't reflect enough to be able to pick up the scan. So I got that first scan to kind of work a little bit, but I want to try to get a little bit better scan on it and see if I can't do something a little bit better before I move on to another project that I have for it. So we're going to test it out on some smaller objects, and we're just going to kind of see what happens here. Not enough features to align, huh? All right, so I have tried a few different ways. For some reason, now it's giving me a completely different issue than what it was the first time I was scanning it. Now it's showing that it's not able to track it properly. So I went ahead and put these little dots. These are called tracking dots. Went ahead and put a bunch of those around the object so that way it has enough features to be able to kind of see what it's doing. And then I've been able to scan it and it looks good. The scan looks really good. So I'm going to go ahead and scan it right now just to kind of show you guys how it works. The main things that you kind of have to remember, again, when scanning, move nice and slow. And then also keep your distance proper on here. And I'll kind of show you what we're talking about here. I've kind of so you can kind of see it's picking up all those little dots. It's helping track it a little better. And you're just going to move nice and slow. You can kind of see on the left hand side there's a little bar that as you're getting in, or if you pull it way far away, it starts to turn blue. So you just kind of want to keep it in that greenish area. I'm going to zoom in just a little bit so that way I can see kind of more what I'm doing here. So again, another one of the things you can kind of do to help with scans is to turn it in different directions and kind of keep going back and forth over some of the areas. And that kind of helps get a few different angles that it can see. So now we let the scan kind of process. All right, so the scan is now done. This is actually what it looks like once you get it done. You can kind of zoom it around. So now something I didn't mention, the colors that are on here, the red, you kind of see yellow and green. The green is where there's enough scan data to have a very accurate scan. The yellow and red kind of decreasing. So, you know, kind of down here, you have a little bit less defined of a scan. There's not as many points in those areas, which again, down here and stuff doesn't really matter. So I'm gonna go ahead and try to scan it just a little bit more to get a little more defined on these ribs right inside here and kind of on this upper section, just so that way I can kind of get a little better scan. All right, so this is the next scan. It looks pretty good. You can kind of see this little dangly piece out here. That happens sometimes when you're scanning. If something falls in the way, like if the cord gets in the way or something, it'll kind of pick that stuff up. Not a big deal. I tried to get a little more kind of in this region, kind of where these plugs are going to be. So that region is kind of where these plugs are, and then this where you can kind of see these ribs right here. Now those ribs are going to kind of be critical when I actually make the adapter for it. So I want those ribs to be kind of as accurate as possible. That's as much accuracy as I could get on that area for what it was, which still isn't all that bad. If you kind of go to preview mode, you can kind of see it a little bit better. And it does look to be pretty good and pretty accurate. These things are going to be about as accurate as they can be. It is what it is. So most of the time what I do with these, which I'll show you guys here in a little bit, is I'll actually take calipers or whatever, and I'll kind of check what my dimensions are on there versus what's on, you know, the actual part itself when I'm actually reverse engineering it. I'm going to show you guys that process here in a little bit, but this looks to be a good scan. So the next steps that are going to be getting rid of everything that you don't need. So you can kind of see down here, there's this little rectangle thing, and what I am going to do is I'm just going to start highlighting data points, and I'm going to be deleting them. Now, the reason I want to delete a lot of this out is because, because a lot of this is not actually going to be needed. So when I actually make the model of this, a lot of the parts that, you know, the table and stuff that you see aren't going to be needed. So if I can trim as much as that out as possible, it will actually aid in the post-processing part of things and make the computer work just a little less hard. Now that I have most of that out, I might try to do just a little bit more just to kind of get some of this out of here. So now that the files have been processed and pushed out in the 3D scanning software, we can now pull them into our actual CAD software to actually start doing the design work. This is kind of a weird process because 3D scanning softwares actually produce what's called a surface file. There's two main file types that 3D softwares use. There's either a 3D surface file or there's what's called a 3D object file. 3D surface files are hard to deal with and to modify because essentially it's a bunch of points that all kind of get used to make planes, individual planes across a part. And then that is what's actually utilized to then kind of create the surface overall, the entire part. Actual 3D object files are actual blocks. They're considered solid blocks, essentially. And so that's what I am doing here is I'm actually converting the surface file into a 3D object file. Now there's 1,000 ways to skin a cat. This is the easiest way that I have found to do it, is to essentially pull the 3D scan, so the surface file, into my CAD software. I can reorient it, and then I can start making planes and drawing those planes down through the object. As I'm drawing the planes down through the object, I'm actually able to kind of create sketches that then will be able to be extruded into a 3D solid object. So as I'm going through here, what I'm actually doing is, yes, I'm using the 3D scan to draw out shapes. So that's what you see with the 3 circles here. Now I'm making little rectangles to be utilized for the actual little guides that are on the battery. So as I'm doing that, I'm actually also in real life holding the part, and I'm actually measuring all of those features as I'm doing this entire thing. So that way I can make sure that what I'm actually seeing on the computer is realistic to what I'm actually holding in my hand. And that gives you a very accurate picture of what you do with this. Once you get all of this done, you can essentially hide the 3D scan. You don't want to completely just delete the 3D scan out of there, because there could be features that maybe you didn't necessarily want to draw inside of there. And so you're wanting to keep that in there just in case, you have a question of, is the end of the battery, or, how is that going to fit in the overall scheme of things. Now that I've actually drawn the actual outside shape, what I end up doing is I end up going around the outside of it, and I kind of push out kind of the outside shape, and I make kind of a little boundary around it. This is going to essentially give me a little bit of wiggle room, so a little bit of clearance in between the individual part and the actual 3D model itself, so the holder. And then once I get that done, I take it in here and I extrude out that section that I'm actually going to use to hold the part. And then after that, I can build a base on the bottom of it. And then I will export this as, again, a surface file, because that's what 3D printers use to actually make the part. All right, so this is the part of the video where I realized that as I'm editing this video at my kid's soccer practice, that I kind of forgot to actually, record the rest of the video. So the next step is to actually create a little test piece like so. The test piece is useful, so within the 3D software, within the actual printer itself, and then when actually the filament cooling can actually shrink or distort the actual part itself. So it's nice to have a test piece that you can easily quickly print out, and it's not the entire thing, so you're not wasting a bunch of material trying to make an entire part, then realizing that it doesn't actually fit on the actual tool itself. Inside of the software, inside of most 3D printing softwares, there's a little scale option that you can actually scale these parts up and down to adjust the actual size of them. And so that's what I did. I made a couple of scaled versions of this to get the exact fit that I liked inside of here. Once that's done, you can toss that to the side and then actually make your actual part that slides right on there. And so that is the actual part itself right there. And this will actually mount up on the wall just like so. And I can have a bunch of these with all of my M-12 batteries on there. So pretty stoked with how all of this turned out. I'm actually going to be doing a lot more with the 3D scanner here in just a few weeks. I got some other things that I want to do. And so hopefully I'll record all that and kind of show you guys what I'm doing with that. Just another note, I'm actually going to be putting these up on Etsy. So I'm going to take a bunch of pictures of these, take some videos of how to actually utilize them. And then I'm going to put them up on Etsy shop. Not the actual parts themselves. I will not be making the actual 3D physical part and shipping them out. What I will be doing is offering up the STL files. So if you have a 3D printer at home, or you know somebody who has a 3D printer, you can buy this pretty cheap. I have a bunch of variations of these. So depending on what way you actually want the battery to sit inside of there, I'll have a bunch of different variations of it, so that way you can put it in any direction and mount it pretty much in any way. And so all of those will be available, plus this little test piece will all kind of come in a package deal inside of just the 3D digital file. Again, this isn't going to be something that I'm going to actually make a bunch of these and actually ship them out, but if you have a 3D printer at home and you want to try to 3D print a couple of these for you, your buddy, whoever you want, you can buy one file, print a bunch of them, give them to your friends, family, whoever, and I think it's going to be kind of cool. So I'll link the description to the Etsy shop down below. I have this, and then I also have kind of a little, I made a couple of quick brackets to actually hold some rags, and so that'll also be in the Etsy shop by the time this video is posted. So like I said, thanks for watching. Like, comment, subscribe, do all of those things, and see you guys next time.